Welcome back to the deep dive. Today we're tackling something huge, what scientists are calling the longevity code.
That's right. For the longest time, living to 100 seems like pure luck, didn't it?
Right. Like winning some kind of biological lottery.
Yeah.
But the science is shifting, suggesting it's much less random.
Far less random. It's more like a set of interconnected instructions, biological and behavioral, that we can actually learn and, follow.
And the big focus now isn't just lifespan, just counting the years.
No, exactly. The real goal, the critical shift, is extending health span. That's the period of life free from chronic disease, being robust and functional.
And we're actually seeing this happen more. I mean, the numbers are pretty staggering globally, over 722,000 centenarians.
It's amazing. And that number tells us something important. Living that long isn't just a statistical blip anymore. It's a verifiable outcome we can actually study.
Okay, so if it's a code, what are the key parts?
Our sources point to four main pillars, all interconnected. First, there's the molecular hardware, what's going on inside our cells.
The genetics and pathways.
Right. Then the inner ecosystem, which is largely about gut health and inflammation. Third, diet and metabolism strategies, how we fuel ourselves.
Makes sense. And the last one?
The last one is maybe the most profound, mind and purpose, the psychological foundation.
Okay, let's dive into that first pillar, the molecular hardware. The genetics part is interesting. Sources say longevity takes two to tango.
Environment and genes. We saw lifespan increase in the early 20th century, mostly due to public health improvements. Cleaner water, sanitation, basic stuff. That's the environment part.
But getting past 100, that extreme longevity?
That seems to need more. It often requires a stronger, rarer genetic advantage, working with a good environment. You need both pieces.
So even if you have decent genes, you still need to manage the cellular machinery itself. You mentioned energy sensors.
Yes, that's crucial. Two key regulators keep coming up. AMPK, that's AMP-dependent protein kinase, and TOR, the target of rapamycin.
Okay, AMPK and TOR, what exactly are they regulating, like cellular budgets?
That's a great way to put it. They're managing the cell's energy and nutrient budget. When nutrients are plentiful, TOR signals grow, divide, build.
Full speed ahead.
Right. But when energy is scarce or the cell is under stress, AMPK gets activated. And AMPK basically puts the brakes on TOR.
So AMPK activation means stop spending, start repairing.
It got it. It shifts the cell into conservation and maintenance mode. And this is where calorie restriction, or CR, comes in.
Ah, okay. I was wondering how that connected.
CR, just consistently eating less, seems to extend lifespan in many organisms, partly because it keeps AMPK more active and TOR suppressed. It nudges the system towards that repair state.
So what we eat directly signals these deep cellular pathways. Fascinating. But there's another system involved, right? Sirtuins?
Yes, sirtuins. Think of them as cellular guardians or managers. Proteins like sirtuin and yeast are key longevity regulators.
And they need fuel to work.
They absolutely do. Their function depends critically on a molecule called NAD plus I. When NAD plus levels are high, sirtuins are active, helping maintain stability, silencing certain genes to prevent chaos.
Gene silencing, like turning down the noise that causes aging.
Exactly, keeping things orderly. But here's the problem. NAD plus levels naturally drop as we age.
Less fuel for the guardians.
Precisely. And when sirtuins lose their fuel, that crucial gene silencing falters. This contributes to mitochondria not working well, and it creates this weird state called pseudohypoxia.
Pseudohypoxia, like the cell thinks it's low on oxygen even if it isn't.
Kind of, yeah. It disrupts energy production as a major communication breakdown within the cell.
So if declining NAD plus is the issue, can we just add more, like topping up the fuel tank?
That's the big idea behind some of the supplementation research. NMN, nicotinamide mononucleotide, is a precursor to NAD plus I. Your body uses it to make NAD plus I.
And we get some naturally.
We do, yeah. It's found in foods like cabbage, broccoli, shrimp, avocados. But the research is looking at supplementation.
And what are the early human trials showing?
They're promising. Studies suggest that taking oral NMN, maybe around 250 milligrams a day, can effectively boost NAD plus levels in older adults.
And does that translate to, like, real-world benefits?
It seems so. Critically, those increased NAD plus levels correlated with measurable improvements in physical performance, things like faster gait speed, better grip strength, and performing better on a sit-to-stand test.
Wow. Okay, so that's a direct line from a specific molecule to actual physical function. That's pretty compelling.
It is. It shows how targeting these core pathways might make a real difference.
All right, let's shift gears slightly. From the inner workings of the cell to the the environment surrounding them. Let's talk about the gut and inflammation. You can't seem to discuss aging these days without hearing inflammaging.
You really can't. Inflammaging is this chronic, low-grade, simmering inflammation that happens throughout the body as we age. It's not like an acute infection. It's quieter, but persistent.
And it's bad news.
It's a major driver, maybe the major driver, of most age-related diseases. Heart disease, neurodegeneration, diabetes, you name it. It's like this constant low fire-damaging tissues over decades.
And the gut is often where the fuel for that fire comes from.
Very often, yes.
Oh.
As we age, the balance of our gut microbes often shifts. That's called dysbiosis, an unhealthy balance.
Okay.
And this dysbiosis can lead to increased intestinal permeability. You might have heard it called leaky gut.
Right. The gut lining gets compromised.
Exactly. And when that barrier weakens, bits of bacteria or their components, like something called LPS, lipopolysaccharide, can leak out of the gut and into the bloodstream.
And that triggers the immune system.
Big time. That LPS translocation triggers systemic inflammation all over the body, and that directly fuels things like insulin resistance and metabolic syndrome.
So a breakdown in the gut barrier literally exports inflammation everywhere else. It's like internal pollution.
That's a good analogy.
Do we see specific gut microbe patterns in people who live exceptionally long and healthy lives, like centenarians?
We do. Centenarians often have distinct, more robust gut microbiomes compared to, say, frail, elderly people. One microbe that gets a lot of attention is Akkermansia mucinifera.
Akkermansia. I've heard of that one. It degrades mucin, the stuff that lines the gut, right? Does that sound bad?
It does sound counterintuitive, yeah. It degrades mucin, but it seems to be crucial for maintaining the health and turnover of that mucus layer. It's complicated.
So it's like necessary pruning for healthy growth.
Something like that. What we see is that low levels of Akkermansia are often found in older people and mice, and this lack is associated with more of that inflammatory leakage we talked about.
Okay.
Conversely, studies where they've increased Akkermansia levels have actually shown reversal of metabolic problems, suggesting it helps strengthen that barrier integrity. It seems to be a key player in a healthy, dynamic gut lining.
Fascinating. And these gut microbes, when they're doing their job, they produce compounds, right? Metabolites, some good, some bad.
Absolutely. The really beneficial ones are the short-chain fatty acids, or SCFAs. Think acetate, butyrate, propionate.
How do we get those?
They're produced when certain bacteria, good guys like Faecalibacterium and Roseburia, ferment dietary fiber, the fiber you eat from plants.
And what do SCFAs do?
They're rock stars. Butyrate, for example, is the main fuel source for the cells lining your colon. But beyond that, SCFAs are potent anti-inflammatories systemically. They actively suppress inflammatory pathways, like one called NF-kappa B.
So more fiber equals more SCFAs equals less inflammation.
That's a big part of the equation, yes.
And on the flip side, the detrimental metabolites.
A major one to know is TMAO, trimethylamine N-oxide.
TMAO, where does that come from?
It's produced when certain gut microbes metabolize compounds like choline and carnitine, which are found in high amounts in foods like red meat and eggs.
And TMAO is linked to?
Unfortunately, higher TMAO levels are strongly linked to an increased risk of cardiovascular disease, heart attacks, strokes, and also higher all-cause mortality. It seems to promote atherosclerosis and clotting.
Wow. So the gut microbes literally turn parts of our diet into something that can harm our arteries.
That seems to be the case, yeah.
Okay, that connection between diet, microbes, and cardiovascular risk is a perfect transition to our third pillar, diet and movement strategies. If the goal is less inflammaging, more SCFAs, what kind of diets win?
Well, you consistently see certain patterns associated with longevity and low inflammation around the world. The Mediterranean diet is the classic example.
Right, lots of olive oil, fish, vegetables.
Exactly. But also the traditional Nordic diet, the Japanese washoku diet, and the Jiangnan diet from southern China, they all share common features.
What are those common threads?
High intake of vegetables, fruits, legumes, whole grains, nuts, seeds, moderate fish, low intake of red and processed meats, refined grains, and especially added sugars and excessive salt. They're naturally high in fiber and phytonutrients.
Basically the opposite of the standard Western diet.
Pretty much, yeah. The Western diet, high in refined carbs, sugar, unhealthy fats, and processed foods, is strongly pro-inflammatory.
Let's dig into the why a bit more. What are the active components in those healthy diets doing at a molecular level? You mentioned phytonutrients.
Two big categories stand out. First, omega-3 fatty acids, especially EPA and DHA from fatty fish. They are precursors to molecules that actively resolve inflammation. They help balance out pro-inflammatory
You're
omega-6s.
balancing the fats.
Okay, and second, polyphenols. These are compounds plants make, often for their own defense. Think resveratrol in grapes, curcumin in turmeric, oleocanthal in extra virgin olive oil, flavonoids in berries and tea.
And these polyphenols aren't just antioxidants.
They are antioxidants, but they do more. They actively interfere with inflammatory signaling. They can inhibit enzymes like COX2, which makes inflammatory prostaglandins, and they modulate key transcription factors like NF-kappa B.
So they actually stop the inflammation signals from being sent out in the first place.
In many cases, yes. They act like brakes on the inflammation cascade. It's pretty powerful stuff, nutritionally speaking.
Okay, so food components acting like cellular managers. Now let's look at the blue zones, those areas with exceptional longevity. What are the really practical, actionable diet tips we can take from them?
It boils down to a few key habits. First, a plant slant. About 80% or more of their food comes from vegetables, fruits, beans, nuts, and whole grains.
80%, that's significant. What about meat?
Eaten rarely, maybe only a couple of times a week, and in small portions like 2 ounces cooked, max. Often used more as a flavoring than the main event.
And sugar, bread.
Very, very low intake of added sugars. And for bread, they tend towards traditional sourdough or 100% whole grain breads, not the refined white stuff that hits your blood sugar fast.
What about the wine? That always comes up with blue zones.
Yeah, moderate consumption, often red wine, is common. Typically 1 to maybe 3 small glasses a day, usually with food and importantly with friends. It's probably partly the resveratrol, but also the stress reduction and social connection aspect.
Ah, the social element. We'll come back to that. Okay, let's switch to the other side of the energy coin. Movement. If we want to boost AMPK, optimize mitochondria, what's the ideal exercise prescription? Do we all need to become marathon runners?
Definitely not. It's more about the Goldilocks principle. Not too little, not too much. The standard guidelines are a good starting point. 150 to 300 minutes a week of moderate activity, like brisk walking, or 75 to 150 minutes of vigorous activity, like jogging.
Plus strength training.
Yes, plus muscle strengthening activities at least 2 days a week. That's key for maintaining muscle mass and metabolic health as we age.
And what happens if people do more than the minimum?
The data suggests benefits continue up to a point. People hitting 2 to 4 times those minimum guidelines seem to lower their risk of early death by as much as 31%.
31%. That's substantial. What's exercise actually doing at the cellular level to fight aging?
It's a really potent anti-aging intervention. It boosts mitochondrial biogenesis, making new mitochondria, and improves their efficiency, their oxidative capacity. This directly combats the mitochondrial decline that's a hallmark of aging.
So it literally builds better power plants for your cells.
Exactly. And it also helps buffer the effects of chronic stress on cellular aging. Specifically, regular activity seems to protect telomeres, the caps on our chromosomes, from shortening too quickly due to stress, especially in people who aren't sedentary.
So it protects our cellular clocks. But you said not too much. Can you overdo it?
You absolutely can. Very high levels of prolonged, strenuous exercise, think ultramarathon training, hour after hour of intense activity, can actually generate excessive oxidative stress and put strain on the cardiovascular system.
So more isn't always better.
Right. It's about finding a sustainable balance. Interestingly, many centenarians in blue zones don't do formal exercise regimes. They practice natural movement.
What does that mean?
It means staying active throughout the day, walking everywhere, gardening, doing household chores manually, standing up and sitting down frequently. It's consistent, low to moderate intensity activity woven into daily life. Consistency seems more important than peak intensity for longevity.
Consistency over intensity. That makes a lot of sense. And that idea of integrating things into daily life brings us nicely to the final pillar, which feels perhaps the most uniquely human. The psychology of longevity, mind and purpose.
Yeah, and this is definitely not just fluff. It has profound biological consequences. Strong social connections and engagement are incredibly important.
Why? How does being connected impact biology?
It acts as a major buffer against chronic stress. We know chronic stress hammers the immune system and accelerates cellular aging, including shortening those telomeres we mentioned. Social support mitigates that stress response.
So friends are literally good for your cells.
Pretty much. Plus, people who are socially connected are often more likely to stick with healthy habits like good diet and regular movement. It creates a positive feedback loop.
That feeling of belonging often seems tied to a sense of purpose, doesn't it? I'm thinking of Viktor Frankl and logotherapy.
Absolutely. Frankel's work is so relevant here. Logotherapy is built on the idea that the primary human drive is the search for meaning. Finding that meaning helps us cope with life's inevitable hardships and suffering.
And that coping ability promotes healthy aging.
Profoundly so. Frankel outlined three main ways we find meaning. First, through creative value, what we give to the world, our work, our deeds.
Right.
Second, experiential value, what we take from the world through appreciation, experiencing beauty, love, connection.
Value.
Right. And third, attitudinal value. This is the meaning we find in the attitude we choose to take towards unavoidable suffering or difficult circumstances. Even when everything else is stripped away, we can choose our response.
That's powerful. It suggests agency even in the worst situations. Now, related to purpose, there's the concept of ikigai. It gets talked about a lot, but often in a sort of simplified way.
Yeah, the Western Venn diagram version where your passion, mission, vocation, and profession overlap, that's a popularization, maybe even misunderstanding of the original Japanese concept.
So what is the original idea of ikigai?
In its Okinawan context, it's much more about the joy of little things. Finding satisfaction in daily life, cultivating your inner potential, embracing hobbies, connecting with community, and being present, being in the here and now.
So less about one grand purpose and more about a way of being, a daily feeling of worth.
Exactly. It's more fluid, more grounded in everyday life and self-reflection, not necessarily tied to career or achievement in the Western sense. It's finding value in the process of living itself.
That feels much more accessible, actually. So bringing this all together, this longevity code isn't one single thing. It's not just NMN or just kale or just running.
Not at all. It's an integrated approach. It's about consistently making choices that support all these pillars. Eating whole, anti-inflammatory foods, moving your body regularly with a mix of cardio and strength, nurturing a healthy gut microbiome with fiber and diverse plant foods, and critically, cultivating strong social ties and a sense of meaning or purpose in your life.
It's a synergy between our biology and our choices.
Precisely. And when you think about how specific molecular targets like NAD+ levels, influenced by NMN, or inflammatory pathways quieted by polyphenols, interact with something as profound as finding meaning or feeling connected, well, it raises a really interesting question for everyone listening.
Which is?
Considering all these interconnected pieces, the biological and the existential, where can you start making small, integrated changes in your daily life that might yield the biggest return on your personal health span investment?
That's the ultimate question, isn't it? Finding your starting point in this complex code.
It really is.
Before we wrap up, just a quick note. This episode is meant to share ideas and insights, not to give medical advice. Everyone's health story is different, so if you're thinking of making big changes to your diet, exercise, or lifestyle, it's always best to check in with your doctor first.
Also, what we've shared here isn't original research. It's a collection of the best science, expert opinions, and findings publicly available right now. And since science keeps moving, some of this may evolve in the future.
So take what resonates, explore further, and most importantly, do what works for you.